Hey, good morning. Hope you're doing well. So this is the second last lesson in Unit 3, and I know we're doing it after the unit test. The reason for that is because it didn't fit in very well with the rest of the unit, so we just decided to make it its own tiny unit alone. So you'll do the quiz for this one, I think, on Wednesday or Thursday. So just look out for that. The good thing is it's reviewing a lot of the things we've talked about, so you're already seeing inverse functions. You guys are pros at inverse functions. Just to recap, we know two functions are inverses if the composition of both functions is equal to the input value. If I get g of f of x, it has to be the same as f of g of x, and both of those have to be equal to x. That's how I know that the function is an inverse function, or the functions are inverses of each other. We have a question here. If I want to show that f of x is equal to 1 divided by x plus 1, and a certain inverse of x is 1 over x minus 1, if I want to show that they are inverses where x is not equal to 0, because if x is 0, then I have division by 0, which is undefined, and if x is negative 1, then I have division by 0 again, which is undefined. So x is not equal to 0. If I want to show that they are inverses, all I would have to do is try to find this composition. F inverse of f of x must be equal to f of the f inverse of x, and both of them must be equal to x. So I'll start by trying to put the f of x as the input for the inverse function. F of x says 1 out of x plus 1, and that's what I put as the input for the inverse function. So I'll have f inverse of 1 over x plus 1. And that inverse function says take 1 and divide it by x, which is what we have here. 1 is divided by x, and then I subtract 1 because the x was this input. And when you do the math, I hope you can see that this breaks down to just x. Same thing on this side. If I take f of the f inverse, I'll use the f inverse as the input, and the f inverse says 1 over x minus 1, so that's my input. However, the f of x says 1 divided by x plus 1. So I have 1 divided by the whole of x, which is the input, plus 1. So that will be 1. When you simplify this, I hope you see it breaks down to x as well. So yeah, you've proved that they're inverses of each other because f of the inverse function of x is equal to the inverse of the function and is all equal to x. Alright, let's try this one. Find the inverse of 5x cubed plus 1. I hope you guys remember how to find inverses. First of all, substitute f of x with y, and that's equal to 5x cubed plus 3, and then try to solve for x. So that will be y minus 3 is equal to 5x cubed, divide by 5 both sides to solve for x. Then I'll have x cubed is equal to y minus 5 divided by, y minus 3 divided by 5. And when I try to find x, that will be the cube root of y minus 3 divided by 5. So the only thing I have left at this stage is to rewrite it and replace my y with x, and replace x with the inverse function notation. So my inverse function of x will be the cube root of y minus 3 divided by 5. And when you graph this one, not y minus 3, x minus 3, because remember you replace the x, saying things that I'm not doing. Alright, so I hope you can graph this and see for yourself that when you graph it, this inverse will be a reflection of the original function in the line y is equal to x. And I hope you guys remember that this is the line y is equal to x, and the property of inverse functions is that they are reflections of each other along the line y is equal to x. Alright, restrict the domain, then find the inverse of this function. Restricting the domain is asking us to state the domain over which this expression is a function. Well, this expression is only going to be a function for, I hope you can see, inside the square root sign, I cannot have anything less than 0. So inside the square root sign, my input has to be greater than 0. And I hope you can see that this shows me that x has to be greater than 4, greater or equal to 4. Now, this x is greater or equal to 4 is my domain for this function. So the domain for this function will be 4 to infinity, right? So if that's my domain, then I'm going to look at the function. The function says f of x is equal to x minus 4 square root. Then I'll try to find the inverse. Remember, this is y is equal to x minus 4 square root, and at that stage I need to solve for x. So to solve for x, I'll start by squaring both sides. So I'll have y squared is equal to x minus 4, and when I make x the subject, I hope you can see x is equal to y squared plus 4, and when I rewrite it, my inverse function is equal to x squared plus 4. But you need to remember, for this function to be an inverse of the previous function, of the original function, I need to make some specifications about its domain. This function, its domain was 4 to infinity. This was its domain, and its range, I hope you guys remember, its range is when x is 4, you can see when x is 4, square root of 0 is 0, so its range was 0 to infinity. And I hope you remember that this for the inverse function, this flips around. This becomes the new range for the inverse function, and this becomes the new domain for the inverse function. And it kind of makes sense, because when you look at this function and you sketch it, it's going to be a curve like this that starts at 4 with a range starting from positive 4 to infinity, and a domain. The only way that this is a function is if it's not a 2 to 1. The only way it's an inverse, not just a function. The only way it is a function, but the only way it's an inverse of this function is if it's not a 2 to 1. And not being a 2 to 1 means it has to pass the horizontal line test. So that means it has to start from here, which is 0 to infinity. Right? 0 to infinity. So yeah, that's how you do that one. And this is the sketch of that graph. I hope you can see the inverse is the one that's up here, and the original function is that one over there. Alright, find the inverse of these functions, x plus 3, x minus 2. All you have to do here is, first of all, say that in my domain, x cannot equal to 2. Yeah? And then after specifying that, you can go ahead and try to solve for x in this function. Solving for x, I just need to replace, I have y is equal to x plus 3 over x minus 2, and then from here it's algebra. I need to cross multiply, and I'll have yx minus 2y is equal to x plus 3, and then I'll collect the like terms. So I'll have I need all the x's on one side, so I'll have yx minus x is equal to 2y plus 3. Then I factor out x, because remember the whole purpose of this is to isolate the x. 2y plus 3, and then I'll have x is equal to 2y plus 3 divided by y minus 1. And now I have to rewrite it as inverse function of x is equal to 2x minus 3, 2x plus 3 over x minus 1. That is my inverse function, and I hope you can see that in this inverse function, x cannot equal to 1. Yeah, that's some of the restrictions. Alright, next one. Find the inverse of this function on the domain negative 2 to infinity. The reason why this restriction is there, I hope you remember, that is that this function, if you graphed originally, will look something like this, and it cannot have an inverse if it is a 2 to 1. It has to be a 1 to 1 to have an inverse. So that's why there's a restriction on the domain, because that's only the part of the function that is a 1 to 1. So to do something like this, I would need to isolate x, or make x the subject, or solve for x. Two ways to do this. One is you can complete squares, or you can use the quadratic formula. If I'm using the quadratic formula, it's the easiest way. Plus minus b squared minus 4ac divided by 2a. I'm going to substitute for the values. This is b, this is a, and this is c. So I have negative 4 plus minus b squared is 16. 4 times 1 times 1 is just 4. 4ac divided by 2. Let's see. Hope I'm doing this right. b squared. Oh, I'm trying to make x the subject. X is minus b plus minus b squared minus 4ac. No, I'm not solving for x. I'm not solving for x. Give me 1 second. Not solving for x. I'm just trying to make x the subject. Let me just complete squares, because this quadratic formula thing is more ideal when you're solving, when it's equal to 0. So I have y is equal to x squared plus 4x plus 1. I need to solve for x. If I want to solve for x, I'm going to first take the one the other side. So I'll have y minus 1 is equal to x squared plus 4x plus 1. No, not plus 1, because I took it away. Okay, so now I have x plus 2 close brackets minus 4. Hope you guys see that this is the same thing, y minus 1. And then on the other side, I'll have y minus 1 plus 4, which is y plus 3, is equal to x plus 2 squared. If I want to make x the subject, I'll take square root, then I'll have y plus 3 is equal to x plus 2. So if I want to isolate x, I'll take away the 2. So I'll have y plus 3 minus 2 is equal to x. Now I have my inverse function, x is equal to y plus 2 minus 3. And I can rewrite it and say my inverse function is x plus 2, sorry, I took square root, only on this one, x plus 2 minus 3. Minus 2, sorry. Where's the minus 3 coming from? Okay, so if I don't want to confuse this to make it look as if the 2 is inside, I'll just write it first. Negative 2 plus x plus 2. That's the inverse of x. That's the inverse of my function. And I know you guys were wondering, when you take a square root, aren't you supposed to get plus minus? Yes, you are right. You're supposed to get plus minus, right? I forgot that. So you're supposed to get plus minus. But now, how do you decide if the inverse is negative 2 plus square root of x plus 2, or if it is negative 2 minus square root of x plus 2? How do you decide? Well, let's look at this. We knew that this was the domain of the original function. The original function had a domain of negative 2 to infinity, so we know that that has to be the range of the inverse function. And the original function had a range of this, I do not know exactly if it is x plus 2 squared minus 3. I think it was negative 3 to something, negative 3 to infinity. But now this has to become the new this domain of the original function has to be the range of the new function, right? And when you look at these two, which of them will give you this range, right? Which of them will give you that range? That's the question you're asking yourself. And I hope you can see that this is the one that gives me that range. Because this one, its lowest point is negative 2 because of that negative 2. However, this one, its lowest point is not negative 2. This graph would start at negative 2 and go downwards. This one will start at negative 2 and go upwards. So that can help you decide. Let me just check my work here. X squared plus 2x. Oh, y plus 3. How did it change to 2? Ay. This has been 3 the whole time. 3. Sorry about that, guys. This was 3 the whole time, not a 2. Thanks for catching my mistake. Okay, yeah, so that's what the graph looks like, and that's the inverse of the graph. You can actually plot this on the graph using your calculator. You can ask me and I'll tell you, or you can look it up on the Google. Use the graph to help determine the domain of this function. The domain of this function, I need to use a graph to help determine the domain. So you just go ahead and graph this, right? Graph it on your Desmos and then see what the domain is. You can also use some analysis and say, if this is a square root function, then everything inside the square root everything inside the square root must be greater than 0, because I can't have a square root of a negative. So that helps you see, because when you cross multiply, the numerator will be greater than 0, and this is telling you that the product of these two numbers has to be greater than 0. So that means both of these two things have to be positive. So either this one has to be greater than 0, or this one has to be greater than 0. And if this is greater than 0, you already have your solution. If this is greater than 0, then you have x is greater than or equal to negative 3, right? The reason I'm saying that is because this product, if this product is greater than 0, then either both of these are negative or both of them are positive, right? Because that's the only way you get something that's positive that's greater than 0. The asymptotes, I hope you can see that x cannot equal to 4, so that's out of your domain. So then you start writing your domain and ask yourself, how can I write this? If x cannot equal to 4, can I have values of this function bigger than 4? Yes. If I put anything that's bigger than 4, I'll get an output. So from 4 to infinity is allowed, right? 4 is not allowed. This is part of the domain. Let's see what else is part of the domain. It's saying x has to be between x is greater than 0 and x is greater than negative 3. But however, you can check this again, because this domain would have to be included. So if x is greater than negative 3, and this is x, then I can't put here greater than 0, because that would be this greater than 0 includes 4, so I need to restrict that. But like I said at the beginning, you can just sketch this on your graph and then be able to see the exact domain of this function. Alright, yeah, so this is kind of what I was going through. Find the x-intercept, find the vertical asymptotes, and then, yeah, this is your homework. I hope you enjoy it. Bye.